tool, CODESYS static analysis. This sounds perhaps a little bit complicated, static analysis. And as I said in the beginning, with static analysis, we find code smells. Before we answer that question, I have to say at first step that of course CODESYS, the CODESYS development system, has an integrated syntax check, and of course as well a cross-reference list. These are checkers which help us to have a syntactically correct code and to see where there are relationships. The cross-reference list shows me where a variable was declared and used as for reading and for writing. This is of course available. However, even syntactically correct code may still carry risks. And these risks are called code smells. Now, I found a definition on Wikipedia. In computer programming, a code smell is any characteristic in the source code of a program that possibly indicates a deeper problem. Okay, very an abstract definition. And maybe you think, does that exist at all in automation industry? Or does it not exist? Are you sure? I have some examples for you. What about duplicated code? Does this happen? Yeah, for example, you're programming and you have some nice algorithm and you need it somewhere else, and because it has to be quick, you just copy the code and use it in another object and think, at the end of my commissioning phase, I will put that together in a function block or a function in order to have just one single source. Be honest, does this really happen? Or doesn't it happen that you have the same code in different locations? Of course, this is not a problem. This is not an error. But once you edit this code on one location, it's of course not edited on the copied location somewhere else, on the duplicated location. And maybe you think, okay, I've changed the code and it's optimized, and then you are wondering why it does not work. And then perhaps it's only because it was executed on this other location. Another topic, missing or too few source code comments. Okay, I know everybody does not really like to write comments. However, these comments of our source code are quite useful, because even if you, after some years, want to remember what you thought by coding it in the way you did, it will be easier for you if you have these comments. Or if somebody else has to check and to improve or optimize or further develop your code, he will be happy to have that comment in order to understand what you have meant with this code lines. So therefore, missing comments can be an indication of a bad code or of a code smell. Another example, redundant code. A piece of code that is not or no longer used. Yeah, you have an object in your project that is never executed. But why is it there? And therefore, it might make sense to have a check of such code. And there are much more examples. For example, peer use objects without code. Yeah, let's assume you have used the UML class diagram and you build up in a graphical way your application because you have it in mind how it should be concerning the relationship between the objects. And you generate these objects by means of the class diagram or even manually, but then you forget to code them, to implement some code. So if there's an empty object, does it mean that you forgot to code it, or was it intentionally? Typical thing is writing on outputs in a multiple way. Of course, this is not a problem, not an error, but how do you know which writing is the relevant one output? Another thing, which is very, very common, you have objects that use variables, something like start, init, stop, end, such common variables which you could use in multiple objects. In case they're just local variables and not in input or output variables, sections, then it might be not a problem. But what if they are even in global variable lists? How can you guarantee that you really used the right variable and that you always used the right variable? Another very typical thing. You're programming, and during, let's say, optimization or debugging, you have commented out some lines of code or some networks of code. But then during the commissioning, these comments are still there, so the code is not executed. Was that by intention, or did you just forget to delete these comments? You wrote a variable, but this variable is never read again. Why would you write it then? And there are many other similar code locations which we could declare as code smells. Syntactically correct code, but this code can lead to a certain problem during commissioning, during programming, but as well during operation. Now, how can we find such code smells? The easiest way, and this is what I always say, you can all do it manually. Just go through your code in offline mode and check carefully for such code smells. So have a list of rules next to you and check, and do not forget to check all these rules. Sounds funny? No. Therefore, I recommend you to get help. CODESYS static analysis. And what is that? It's just like a dog sniffing around for such code smells. Yeah, so this dog will help us. Of course, it's no dog, it's just a picture. And for that purpose, I show you how this is integrated in CODESYS. And again, I switch back to the CODESYS development system, switch in offline mode and come back to my project. The first step, I want to show you where you can find these options. That's under Build, Static Analysis. There's an additional command section, and you see that we have 4 commands there. Run, settings, view metrics, detect clones. Let's start with the settings. Of course, I can save and load my settings, so I can transfer these settings to another computer or restore them from another project that I've checked. And I can even activate here that the static analysis is performed automatically. I won't do that, just in order to shorten a little bit the presentation. The most important thing are the rules. As I said before, we have certain checks that we want to check the code with, and these are defined within the rules. And you see there are multiple rules. In total, there are far more than 100. For example, unreachable code, empty objects, check subrange types for arrays, for example, arrays with only one component, address operator and constants, complex return values, untyped literals, possible truncated strings, and many other things. You see that I can now activate and deactivate the rule for my check. Yeah, just clicking it. And you see that we have not 2, but even 3 different states. The first state is that code smell that was found by such a rule is reported as an error. So this means you have to check it and delete it first somehow, or you can report it as a warning. Just click on it once again, and it's in that grade mode. Then we can define several such checks for the precompiler. Some rules have even some rule-specific configurations, and here's even a list of importance. This was just copied by a standard book which defines such rules for code smells, for finding code smells. And you can see that I've kind of course structure by importance or by the moment of execution or by the default, which is the rule number. This rule number is somehow important because we are able to deactivate on certain locations the checker, not globally, but only in a certain location of it. Here's a question. I have the professional version installed. I can see the SVN in my project menu, but I don't see static analysis in my build menu. Maybe you have an old version where it's still in a different location. So perhaps just update the CODESYS development system or the CODESYS SVN, then you would find it as well under build. Okay, now let's skip all the other options and settings here. We'll come back in a minute to that. So what we want to do at first step is run static analysis. So now all the activated rules are now used in order to check the code. Of course, this takes us a while, but not too long. It gives me the possibility to check the questions again. And you see, whoa, there are a lot of errors found here. And if you are familiar with the message window, you could find that there are different categories. And of course, there is now a new category, static analysis messages, and they have this certain paragraph sign in front of. And you see that they have these famous rule numbers. And I can now go step by step through the list and step to the single locations and check whether this was intended or not. And as I said before, I can even find a location and deactivate it for that certain position here. In order to do that, I just activate the online mode here, the online help here, going to the add-ons, going there to static analysis, reference programming, and can find there pragmas and attributes. And the usage is quite easy. You use an attribute called analysis, which is put this parenthesis and the rule number with a minus in front. And then this check is at that position deactivated. And you can activate it again in this way here. You can even do that for multiple rules. So you have a very fine granular possibility in order to switch on off these rules for certain positions. Maybe it's a good idea here again to make a comment why you deactivated the rule checker. So just as a small hint here. Okay. Let's go to the further checks. There's another question. Possible answer to the last question. Maybe it's still the old buyout version of single professional developer edition tools. The new PDE works as a subscription model, including all 5 tools. Yeah, as I said, you need to update, but you can as well update the tools without changing the business model. So if you have already bought that tool, then you can do the update nevertheless. However, there might be a break, someone maybe as soon as we have the new Git version control included, then it's no longer included to the older licensing model. Okay, however, let's go to the settings menu once again. We have seen the rules and how to use them. There are some more possibilities. For example, we can check for naming conventions. It's a good idea if you define in your company naming conventions for using variables, objects, and other typical names. Yeah, you can see for types, scopes, vars, POUs. It's a good idea to have some prefixes in order to make it easy to understand what we are talking about. So typically an X is used for a Boolean expression. So I can just type an X in here, or a byte for a B for byte, or I don't know, a W for word and things like that. And then the checker will find these locations too, where you didn't use these naming conventions. Makes the code easier to understand. Of course, it's not an error to do it without the X in the Boolean variable. However, it's easier for your colleagues or for yourself in the future to understand what you meant. The same way you can have forbidden symbols, which you do not want to be used in the project because you do want to avoid interference with other objects, or they are just not fancy or whatever. Last but not least, there's a category for so-called metrics. Metrics are derived values that categorize or that, let's say, give you an impression of your project code in general. What are these metrics for? For example, for checking the code size of an object, variable size, stack size, which are quite obvious values. How often they're called in task, this is not that obvious anymore. And then there are some derived values that you can use in order to get a kind of quality impression of your code. For example, how is the complexity? There was a guy called McCabe who has realized a certain algorithm in order to give a value for that complexity, or the complexity of nesting. Another guy, Prather, defined such a value. And there are multiple of such metrics you could use in order to get an impression of your code quality. I can run that. Again, this takes a certain time because we've seen there were multiple of these metrics activated, and you have even seen that some of, or all of these metrics may have a minimum and a maximum value. So I can really give or get an immediately overview where I exceeded these minimum and maximum values in order to check perhaps these code parts again, especially in order to be sure that this was not a problem. Yeah, you see immediately here, okay. So the variable size is over the limit of, I think, 100, which I've entered in there. And I see here the complexity values, and I can, of course, even sort by the name of the unit, by the code size, variable size, stack size, and all these other parameters that I have derived from the project. What I can do furthermore, I can derive a graphical overview on these values by clicking on the values I want to show. Let's just take some of them. And with right mouse click, I can now generate a so-called caveat diagram showing me immediately in a graphical view where I am inside these minimum and maximum values. This is the white area in here, or outside the gray areas lower to the center or outside the center. Okay, so this was the metrics. There's one more thing I can show you. On the build static analysis, I can even detect clones inside the tool. So I'll let that run again. And you see the clone checker was running through my code, and it finds two POUs where I have obviously the same code. So perhaps I take a look at that. I mark both of them, show selected clones, and see, okay, this is my simulation application, and there is another aux POU. Of course, I've just intentionally made that in order to be able to show you something. Otherwise, I would never duplicate codes. This tool helps me immediately to find it. Yeah, so I can see, oh, it's really the same code. And would be even detected if only the variables are differently. So if there's just a counter 1 or 2, so the literals are different, but the code itself is identically, the clone detection would even find that too. I have here some options, some summaries, some results. And what I can do even more is to click on one of these locations where the duplicated code was found. Now this duplicated code is already marked. And now there's something really miraculous. I can right mouse click and use refactoring and extract that code here into a function guided by the tool. I have to admit that this only works for the structured text, for this programming language, which is similar to Pascal, so not for the graphical languages so far. However, structured text is quite often used for programmers who are very familiar with high programming level languages. It's nevertheless a fine and useful add-on. So what can I do? I see that this code was marked. The tool immediately makes a proposal for a function name, get iCounter, shows me the input and the return values, and I could immediately create such a new function in here. Where is it? Good, iCounter, which is then as well called by that position here. And this would work in the same way. I just undo it because I want to be able to show that project and the same presentation perhaps once again later on. Okay. But you have seen, if you have duplicated code, and as I said in the beginning, it's quite often that you just quick and dirty copy code somewhere and forget about it. At the end, you can put it together, make an optimization, and get the code more compact and more efficient. And especially for the further engineering of the code, it's a huge effort. It's a huge increase of efficiency. It's a huge benefit. Okay, so you've seen that we have multiple possibilities using numerous rules. We have implicit code check. I didn't show that so far. I will show it in a screenshot in the next slide. You can have implicit checks during translation of process, explicit by command. You have these statistical key figures for code quality, these metrics, and you can check on code clones for identical program code. And this is what I just mentioned. In case you activate the code check during programming, you get such so-called smart tags. And you can then, for example, have here an unreachable code, and you could just remove it with a mouse click, or do it in the message window. Then I showed you that you can exclude from check, either deactivate the rule completely or only for a found location. You can find code clones in that structured text editor and rate outsource it into useful peer use. So as a conclusion to CODESYS static analysis, I'm sure that everybody that programs has such code smells. In most cases, they won't bother us. Then we're happy guys and we don't need to care for them. In some cases, they will bother us. So it might be a good idea to start to check for code clones and to train yourself to avoid them. And by using such a tool, think of the dog that sniffs for that problems, it's much easier to find them and to fix them. And you can, of course, just switch off the rules that you're not taking care of. However, I can really recommend to use that CODESYS static analysis for real applications.